Hey Leanna, thought I'd show you a quick Bayes theorem. So let's just say we started off with that there were 55% girls and 45% boys. And of the girls, 60% made their beds while 40 didn't. And of the boys, 40% made their beds and 60% didn't. We call that the complement. We can use the tree diagram whenever we want to do Bayes' theorem or reverse probability. For example, say I want the probability that it's a girl given they made their bed. Well, first you would just have to remember what the probability of A given B is defined to be. Remember, we're limiting ourselves, saying B has already happened. So we're saying out of all the outcomes, how likely is it that B happens? And of those, how likely is both that have happened? So this here is how we're going to solve the problem over here, girls given bed. So obviously the denominator has to then be probability of bed. There's two ways that we could get someone making their bed. They could be a girl and make their bed, which would be 0.55 times 0.60. Or they could be a boy and make their bed, which would be 0.45 times 0.40. The numerator would have to be both of them happening. So for our example, that would be a girl and makes her bed, which would be 0.55 times 0.60. And if I plug that into the calculator, I will get my answer. So again, the denominator is the probability of making their bed, which we could get really two different ways. We could have a girl in bed, or we could have a boy in bed. And the top, which is both happening, would have to be girl in bed, which is 0.55 times 0.60. Here's another example, Leanna. Let's just say that the probability of a person has cancer is 0.001, and the probability they don't have cancer, therefore, is 0.999. If they have cancer, the likelihood they test positive is 0.99 versus negative 0.01. The probability, well, if they don't have cancer, the probability of testing positive is 0.01, and if they don't have cancer, negative should be 0.99. So if I say to you, what's the probability that they don't have cancer given that they tested positive? Using our definition of conditional probability, this would be the probability that they have cancer and tested positive over the probability that they tested positive. Well, the probability that they tested positive, we can see from here, could happen from when they have cancer and positive, which is 0.001 times 0.99, or when they don't have cancer and tested positive, which is 0.999 times 0.01. The numerator would have to be when they have cancer and test positive, which would be the 0.001 times the 0.99. And if you do this on your handy dandy calculator, you should get the answer. Hope this helps. Love you, babe. Bye.